We'll talk about these other guys.
It's about
Secants.
tangents.
Okay. Okay, we're back to the trichotomy again. So no intersection, one intersection, two intersections. That second intersection is called the secant, which is really kind of confusing because we learned about the trig function of tangent. Then we talked about the physical object of a tangent line. What we didn't talk about is that there's three other trig functions. Strangely enough, the other three trig functions are called secant, cosecant, and cotangent. Well, now all of a sudden we've got a physical object of a secant. This is so confusing. Shouldn't be confusing for you because you don't know what a secant is, but for someone like me who's doing trig and, never mind. You don't need to hear about my troubles. Intersects a circle in 2 points. Or if you'd like to think about it, it's a chord that's extended into a line, as Tom mentioned earlier. Proud of that, aren't you? Mm-hmm. You dog. Okay, so we get all kinds of bizarre theorems with the secant here. This is gonna get weird. If I can get my pen to work. Come on, pen. Come on. Oh, there it is. Whoa, I skipped a couple, didn't I? Okay, so we want to be here. This is where things get weird. So now we're going to combine a tangent with a secant. So in that picture, AB is my tangent, and BC is a secant. I eliminated the other part of the line because it doesn't matter. You can write all that down, but before you do, let me summarize it for you with a question. Where's the vertex?
Of what?
The angle.
B.
Good. And where is it located?
At the intersection.
On the circle. That's the key. Because if the vertex is on the circle, what's the relationship between the arc and the angle?
It's arc is 2 times the angle.
Beautiful. The arc is 2 times the angle, or the angle is half the arc. Right. So it's no different than the inscribed angles we've done. It's just that in the inscribed angles, you've got 2 chords running through the circle. In the secant tangent, part of that angle kind of flies outside the circle, but the relationship is still the same. So if you want to write all this down, you can, but you don't really have to because it's the same thing. It's that 1 to 2 relationship there. Okay? So first things first, if arc, I should have put another point over here. So let's say there's a point K's over on that arc. If arc PKS is 250, how big is arc PS? 110. Good, because they both have to add up to be 360. Therefore, how big is angle raccoon, puma, squirrel?
That's 110, 55.
55, good, because it's half of the arc measure. And if raccoon, puma, squirrel is 55, how big is quail, puma, squirrel?
125.
How much?
125.
125. Why, Matt?
Because it's half of 250.
Oh, I guess you could have just done that. Good job, Matt. So we don't really care about RPS.
RPS?
Yeah. Or angle RPS.
Yeah.
Right, so I did it the hard way.
Yeah.
Could have just taken 2. I'm an idiot. Let's move on.
Are you recording, Mr. Reedy?
That I'm an idiot? Yes. Okay, third scenario. This is weird. Third scenario, we put the vertex inside the circle but not at the center. So now we got at the center, on the circle, inside the circle. If it's inside the circle, it intercepts 2 different arcs, as you can clearly see in my illustration. What you need to recognize is that these 2 arcs, sorry, let's back up. The angle, by the way, what do you know about angles 1 and 2?
Vertical.
Vertical, which makes them congruent. Okay, so one of these, let's say angle 1, is going to be equal to the average of the two arcs. How do you find an average?
Add them together and we'll divide by 2.
Multiply by two.
No.
Did you think we were in the speed round or something?
If you're in first, relax.
Thank you, Ricky Bobby.
You're welcome, Mr. Reedy.
Uh-huh. Got it? Average. So again, you could write all this gunk down, but it's written in a foreign language anyways. You just need this picture, or even better, summarize it with your own words so that you can remember what's going on. If it's inside the circle, the angle is equal to the average of the intercepted arcs.
So if you're trying to find measure of angle 2, then you do the same thing?
Because 1 and 2 are equal. And if I wanted to get all fancies in my pantsies and do something like this and call this angle 3, how would I find angle 3? A couple ways to find angle 3, by the way. Go ahead.
Well, if you know angle 2, then you can subtract it from the
Okay, good. Yeah, that would be the easy way to do it. I was, again, going for the difficult method, which would, yes?
If you know angle 1, you can subtract from the rest of 180.
Yes, that is true. Thank you. You could also take the average of arc AC and arc BD. Add them up, divide by 2, would give you angle 3, which would also be the same way you could find angle 4. And when you know about all 4 of those angles?
Yeah, that's 360.
Add up to 360. All right. Fourth scenario, we move the vertex outside the circle. So I got 2 secants coming through there. Forms an angle. Again, you could write down all this gunk. You could write down this, but I'll give you a nice easy buzz phrase to remember here. Big arc minus little arc divided by 2. Stop writing for a second, look up here. Does everybody understand the fact that the arc that's farther away from the angle will always be the big arc?
Yes.
Yeah.
Did I hear a no?
I said, yeah, kind of late, but.
I understand. Yeah, late to the party.
Yeah.
Big arc minus little arc divided by 2, or times a half, it's up to you. We'll give you the angle measure. Way back when in the beginning of the chapter, I said one of the questions I was going to continue to ask you is where's the vertex? Now it becomes very relevant. Is it on? Is it at the center of the circle? Is it inside? Is it on? Is it outside? And each one of those has to be handled differently. On your way. You good? Yeah, you good now? Okie dokie. Let's start with the question, where's the vertex? Outside. So when it's outside, the relationship is big arc minus little arc divided by 2. The problem is, I don't yet know how big hippopotamus, jaguar, kangaroo is. No, we've heard enough out of you today. No, you won the speed round, so now you get to take a break. Machek.
Can't you say 360 minus 102?
That's exactly what you would do. The blue arc and the red arc add up to be 360 because it makes the whole circle. Therefore, arc hippopotamus, jaguar, kangaroo would be 258. If my math is correct.
Yeah.
Okay, good. So the big arc is the blue one because it's farther away. 258 minus 102 divided by 2 tells me that it is, we have a confirmation, 78. Is everybody good with that? See? Bueno, gracias. 78.
Wait, how did you get 78 from? How did you go from 258 to 78?
Big arc, 258, minus little arc,
Got it.
bucko 2, divided by dos. That's Spanish for 2. Gives you 78. Golden. Woo. Scariness. Let's go backwards. Logically, it would seem like, well, let's do angle 1 first. We're going to buck the trend here. How big is angle 3?
50.
Julia. Good. Why?
Angle 3 is half of.
Why? Beautiful. Angle Angle 3 has the vertex on the circle, therefore it's an inscribed angle, and as she so astutely pointed out, it is half the measurement of the intercepted arc, therefore angle 3 is 50, well done. How big is angle 2, Faith?
Hold on.
I'm holding. I ain't going nowhere.
Is it 12.5?
Why?
Because it's 25 divided by 2.
Why?
Because the vertex is on the outside of the circle,
Perfect. Just on the circle.
or on the
Yeah.
circle.
And we don't want to throw in that O word because it's going to confuse us. Okay. How big is angle uno? That's Spanish for 1, Emily.
Would it be 37.5?
Where did that number come from?
100 minus 25 divided by
Beautiful. Because the vertex is where?
2. Outside.
Outside. And when it's outside, it's big arc minus little arc divided by 2. And I'm assuming that 100 minus 12.5 divided by 2 is 37.5? Did you do our math right, everybody?
Wait, what did so you do 25 minus 12.5?
Oh, no, sorry, not 12.5. I was wrong. 25. 100 minus 25 divided by 2. Yes, I know that the half of 75 is 37.5. I lost my brain there for a second. Okay, everybody good? No problem so far? Good. Now we throw some algebra in, because it's good for you, it builds character. Before you even start thinking about angle measures, what do we know in that picture? Natalie?
Angles, Jaguar, Tyrannosaurus, Mammoth is equal to lemur.
Did you say mammoth?
Yeah.
Excellent. I just watched a piece yesterday about how they're trying to genetically engineer the woolly mammoth back into existence because it could help stop global warming by creating tundras where they're out there. It was pretty fascinating. They had this like frozen mammoth that's been, they found that, and they were taking shavings of the tusk and they're either gonna try to match that with an elephant or grow it from scratch. So we could have woolly mammoths roaming around in a couple of years.
Pretty sick.
I just like a woolly mammoth walking down the street.
Why can't they?
Like
do
at
that?
local carnivals.
Yeah.
But Mom, I wanna ride the woolly mammoth.
We'll see you next on one of those animal attacks.
Just wait, I've got a special treat for all of you today.
Really?
Hi.
I was motivated by the animal attack videos yesterday.
Oh,
You'll see.
God.
Is it entitled?
Oh, it's on the last
hold on, I don't
slide.
wanna-
It's on the last
Yes,
slide.
it is on the last.
Just consider that a teaser. Alright, so back to you, what about woolly mammoths?
I was saying that angles, Jaguar, tuna, mammoth, and lemur, Tyrannosaurus, tortoise are equal to each other, so the arcs are equal to each other.
Good.
And then you can find x that way by setting two arc lengths.
But there's a small problem with your statement.
Okay,
They're not necessarily equal.
never mind then.
They would be equal if T was the center of the circle,
Oh.
and we don't know that. Listen, you used the wrong word. Yeah, all the arcs add up to 360. Okay. That has nothing to do with the chords that are drawn through the circle. That just has to do with the fact that I took that circle and broke it into 4 arcs. And those 4 arcs have to add up to 360. So that would allow us to find x. Do that, please. Because we're going to need that information in a second. Question?
Couldn't you do it another way though? Because they're vertical angles, couldn't you
Just because those are vertical angles doesn't make the arcs congruent. Because it's not the center of the circle.
Oh, yeah, my bad.
Tom, find x.
What? Oh, yeah, no.
Well, like that.
I
I'm not that fast.
You're like a walking ad for Nike today. You got Nike headband, Nike shirt, you got Nike sweats. Are you wearing sweats or
No, they're Under Armour.
you got? Oh.
Ruined it. I did.
I'm wearing Nike.
And you got
too.
Converse shoes on?
Wait, how is my Nike? Oh, it's
There's
oh,
Nike.
here.
I'm wearing Nike.
Good for you.
Yes, I do.
Thanks for sharing, Tom. What's X?
One.
1?
What?
Yeah.
All right, I can work with that. Oh, that's easy math. 104. Ooh, that's a bad color. One, it says it's a 1 is 30, 40. And then 38. And then 178. Okay. Okay, now how do I find the angle? What'd you say, Jaguar, Tuna, Llama? What'd you use for L?
Lemur.
Lemur.
You said
Oh, good.
Tyrannosaurus.
I'm sorry?
Not for owl. You said for owl.
For T, she's
I know,
gonna
but for
say.
T, you said
Faith.
tuna.
Answer a question.
Because I use both.
Not anymore. I was gonna give an answer, but it's not right.
Oh,
I don't think.
Oh, come on. Fire it off. What's the worst that could happen? You're wrong. We all turn around, point at you until you're mocked into oblivion and have to run out of the room crying and go pet the dog, and you drop this class. And eventually, when you turn 16, you drop out of high school and can't really find a job except in Amico, sitting behind that big, thick plate glass window with a shirt that says Faith on it. You just get tired of asking people what pump were they on, and do they want cash or credit, and do they want to put that beef jerky and Mountain Dew on the credit card or pay cash for it. And then you realize your life isn't really going anywhere, so you quit that Amico job, and then you're out of job, so you have nowhere to live, so you get a big refrigerator box. And you're living in downtown Mount Prospect in a refrigerator box, colored with crayons to look like a real house, so you go into your little refrigerator box and you feel like you're at home because you have the illusion of the walls painted, and that's your existence, all because you were afraid to give an answer. I mean, that's not that big of a deal, is it? Go ahead.
Quite
I was
story.
gonna say it's 104, but then it's not in the middle.
Beautiful. So you
So-
gave an answer which you realized was wrong, but you realized it was wrong.
Yeah.
That's not so bad, is it?
Sure.
Doesn't require a large amount of mocking, just a little bit. We'll save it for the end. Dorita, what do you got?
It's 141.
Why? I don't remember if that's the right answer or not. Okay.
You add 104 plus 178 and then you divide that by 2.
Why?
Because that's the theorem.
Where's the vertex?
G.
I mean, but where's it located? Sorry.
Oh, it's inside. So
Inside the circle. Well done. So I'll trust, is her math right, by the way? 104 plus 178 divided by
Wait,
2?
but if you, is it because like if you flip it up, then it would be like the bigger angle?
No, it doesn't matter. When you're doing inside, we don't care which one's big or small because you're just doing an average. So she took the average of 178 and 104. Inside average, outside we need big and small.
So you do 1/2 the bottom, the bigger one plus the top?
You got it.
Okay.
Okay. Okay, we good? Yeah, okay. Ooh, we're running out of time. Okay. Quarter after, right?
Yeah.
Okay, good. How big is this arc over here? Any idea? Other than 4x plus 5. The answer to that would be
2 x plus 2.5.
Say that again.
Oh, never mind.
Okay. So again, if you get jammed up and you don't know what you're doing, ask yourself a simple question. Where's the vertex? So, where's the vertex? It's outside. And what's the rule when it's outside the circle?
big
Minus
minus
small.
small.
So before x plus 5 minus 50 divided by
So the angle is equal to big arc minus little arc divided by 2. Nice algebraic equation, not too bad to solve. You can solve for x, and then I can also ask you how big the angle measure. I can ask you a whole bunch of other things, but you got it under control. 25. Okay, so this isn't animal attacks videos, but it is, well, you'll see why. I'm gonna have to close the blind for this. And some of it drags on a little bit, and there's some weirdness in halfway through. I'm not a gymnast, but if you were a gymnast, you might understand this. I don't get it. But this whole video is worth watching for the last one. Let's see what I'm talking about when it gets there. So this is human failures
Oh, that's great.
with a gymnastics theme to it.
Oh!
So this is just mistake after mistake of, some of them are humorous, some of them are quite painful, like that one. Like how did she not break her neck? That one.
Oh, what a
She
snag.
caught herself.
Oh, that one she just
Oh,
oh, this one.
Oh, see you later.
Looks like
Whoa!
I'm sure she broke both her legs. That one just sat
But I
down.
think she hurt her neck. Oh, no.
Whoa!
Oh, she was so close.
That's not gonna end
Oh!
well. Oh, bird's eye view.
Oh!
Yeah, that I don't know why anybody would do the beam. Is anybody a gymnast, by the way? Yeah. Do you do the beam?
Well, I used to be a gymnast, but
Oh,
I did
okay.
volleyball.
But then you realize that this could be your life, and you
Oh, I did a lot of these. Like, I fell
like
over the field.
that. Some of these are from the Olympics too, so they're doing. Oh, they're doing this on an international stage. Like that guy.
Oh,
did
she
this.
was. Oh!
Second?
That was
Not good. Not good. Ooh,
Oh,
she just
God.
went all wonky on it.
Regular human fails.
Oh, that was awesome.
Oh, that's
She like
Oh, that's an American, by the way, and she died. I'm kidding. She didn't die. She didn't die.
Oh,
That was a good one. Oh, slow-mo is not good.
Oh!
If that was a guy, he'd be dead.
Oh.
Ooh, that had to hurt. That wasn't too bad.
That like hurt her heart, I could tell.
Yeah, oh, yeah.
Oh,
More painful in the heart.
No, I don't like this one either.
Oh.
she fell on the ground.
Oh.
In case you missed that last one, she completed the flip, but then she did little twinkle toes and fell on the twinkle toes. Dead.
Oh, that's a good
She
one.
probably, oh, she hurt herself there. This is a good one. I like this one. Oh. Oh.
Oh, yeah, get back up there.
There you go. Oh! This is a good one. Watch this. Oh! See, now I don't get this. Apparently, is this a famous gymnast or something,
Yeah.
Julia? Do you know?
She's a decent
I don't.
It is. She's,
I don't know what this means. She's Savito, the famous gymnast.
yeah, she's I mean, most of them.
Maybe she was like qualified for being like on steroids or something.
I thought that was gonna end a lot worse.
Yeah, me too.
Hey,
That was
oh,
kind of cool.
With a nice little pirouette there. Oh, slow motion nonetheless. That was a little hard to see, but she's holding Mrs. the bar.
the legs came out.
Oh!
Oh.
Yeah, that would hurt.
Just one.
Where's the
Oh.
Here it comes. Wait for it.
Are we gonna finish it?
Yeah, we'll finish. If not, it's worth staying for.
She thought she was gonna
Oh, that was kind of.
He's like,
Nope.
No.
Oh! That's a bad one. That's a bad one. He almost kicked himself in the back of the head.
Oh.
Yeah, those are just uncomfortable. It makes my neck hurt. Her too. She's dead. Come on, come on, come on, come on. Looking good, no problems. And then she went all crazy.
Okay, she saved it.
Broken toes.
That one.
Wait for it. Trust me, it's worth waiting for. Hold on. It's coming up. Slow motion. Who cares? Get off the beam. Wait for it. Wait for it. Here it comes.
Oh, there you go.
Slow motion. Hold on. Slow motion. Here it comes.
No way.
Kaboom!
Have a great day, everybody. Hey, Tom.
Thank you.
that ended his life.
Thank you.
Yep.